In this lesson, we're going to cover Unit 6, Acquisition 1 on significant figures. So we talked about significant figures briefly first semester when we did average atomic mass, but we're really going to focus on them second semester because we do a lot more calculations. So every calculation that you do from now till the end of the semester, you should round your answer to the appropriate number of significant figures. Well, why are significant figures so important? Significant figures, which we'll usually just call sig figs for short. Significant figures or sig figs indicate how precise a measurement really is. So if you said the mass is about 5 grams, that's not a very precise measurement. If you said it is 5.0 grams, that is more precise. If you said it is 5.000537 grams, that number is super precise. So think about when you do calculations in your calculator and you get like 8 or 9 decimal places. We don't want to record all of those decimal places because that's indicating that your number was recorded to a higher degree of precision than what the balance can actually record. So I know we are virtual right now, but if you were to take a measurement in our classroom, our scales can only measure to 2 decimal places. So we want to make sure that we're recording our answers within the realm of precision which it actually was measured. So there's a bunch of rules for sig figs. So we'll go through them with some examples. Rules for determining the number of sig figs. Rule number 1. All non-zero numbers are significant. All non-zero numbers are significant. Let's say your number was 1.23. I have 1, 2, 3 digits. They're all non-zeros. This number would have 3 significant figures. Let's say your measurement was 2.4. I have 1, 2 digits. Neither is a 0. So this number has 2 sig figs. Rule number 2. Zeros between significant figures are significant. So if we have a 0 that is sandwiched between 2 significant figures, by default that 0 is significant as well. So let's say the number was 509, and again it all comes down to how precise the measurement is. Obviously if we've measured to the ones place, the tens place has been measured as well. So the 5 is significant, the 9 is significant, a 0 sandwiched between would be significant as well. So this number has 3 sig figs. Let's say we had something like 1007. So again, non-zero numbers are always significant. So the 1 is significant and the 7 is significant. All zeros between sig figs are also significant. So both of these zeros are significant. This number would have 4 sig figs. Zeros are not always significant. leading zeros are not significant. A leading zero is any zero that leads the number. Like let's say 0.0001. Any zero that comes before the first non-zero number is considered a leading zero. So all of these zeros are leading zeros and they're not significant. This number has only one sig fig. So this works also if this number were written in scientific notation. If we were to write this into scientific notation, it would be 1 times 10, 1, 2, 3, 4 to the negative 4. And again, this number has only one significant figure. Let's look at another example. 0.0000000027. Again, it doesn't matter how many zeros you have. Any zero that comes before the first non-zero number is a leading zero and it's not significant. So this number only has 2 sig figs. And again, we can write this number in scientific notation. We move the decimal 1, 2, 3, 4, 5, 6, 7, 8. So whether it's written out longhand or in scientific notation, this number still has 2 significant figures. Rule number 4, trailing zeros. So leading zeros are at the start of the number. They lead the number. Trailing zeros trail or at the end of the number. These ones are a little bit more difficult. Sometimes they're significant, sometimes they're not. Trailing zeros without a decimal point are not significant. So let's say our number was 120. So this is a trailing zero. It is at the end of the number, and there is not a decimal point. Non-zero numbers are always significant. Trailing zeros without a decimal are not significant. This number would have 2 significant figures. And again, it doesn't matter how many trailing zeros you have. If there's not a decimal, they're not significant. Let's say my number was 15,000. This number would still only have 2 sig figs. If you had a number like 15,000 and let's say you needed 3 significant figures, the way we can do that is by putting it in scientific notation. We're moving the decimal 1, 2, 3, 4 places. So this number would represent 15,000 with 1, 2, 3 significant figures. And this brings us to our last rule. Trailing zeros after a decimal point are significant. So 2 examples. 0.0230. Leading zeros are not significant. Non-zero numbers are always significant. A trailing zero, which is a zero at the end of the number, if it's after the decimal point, it is significant. So this one has 3 sig figs. Sometimes students count this zero as significant because it's after the decimal point. The reason the zero is not significant is because it's a leading zero. It comes before the first non-zero number. The second example, non-zero numbers are always significant. Trailing zeros, zeros at the end of the number, if they're after a decimal, they are significant. So this number has 4 sig figs. All right, next, I'm going to give you a number and we're going to round it to a different number of significant figures. So let's say my number was 1,245.53. We're going to round it from 5 all the way down to 0. All right, so let's say we have this number and we want to round it to 5 significant figures. Right now it has 1, 2, 3, 4, 5, 6. We want to round it to only 5 significant figures. All non-zero numbers are significant. 1, 2, 3, 4, 5. So now if we're going to take this number and round it to 4 significant figures, I'm going to keep the first 3. The next number, if it's 5 or above, we round up. 1,246. We're always going to round based on the original number. So let's say I had this number and I wanted to round it to 3 significant figures. So I'm going to keep the 1. I'm going to keep the 2. Here is a 4. The next number is 5 or above, so we're going to round it up. The biggest mistake that I see students do is they write their number as 125. It has 3 digits, 3 significant figures. Let's say I owed you $1,245.53, and I gave you $125. Would you be happy with that? Is that number the same? I rounded it. No. So the way that we round this number to only have 3 significant figures is by putting a 0 there. If we add a 0, it is a trailing 0 without a decimal point. So this 0 is not significant. If I owed you this much money and I gave you 125, or if I gave you 1,250, you would probably be more happy with this number. All right, if we're going to 2 significant figures, what I want to point out with this one, we're rounding the original number. So the first digit I'm going to keep. The second digit is a 2. I only look at the one number that comes after it, and it's less than 5. So if I were rounding this number to 2 significant figures, I would keep it at 1,200. What you don't want to do is double round. You don't want to say, well, this 5 rounds the 4 up to a 5, and then if this is a 5, it rounds the 2 up to a 3. If we're keeping 2 significant figures, keep the first 2 digits. Look at the one number that comes next. If it's less than 5, do not round it up. If it's greater than 5, round up. And then 1 significant figure, our answer would be 1,000. So the last thing that we have to talk about for today is how do we round when we're doing calculations. when adding or subtracting, you are going to round the answer to the least number of decimal places. So let's say I had 4.67 plus 9.376, and my answer was 14.046. And we need to round this answer to the appropriate number of significant figures. Since I'm doing addition, I'm going to round it to the least number of decimal places. My first number has 2 decimal places. My second number has 3 decimal places. We're going to go to the least number of places, which is 2. So I'm going to keep 2 decimal places. And since the next number is greater than 5, I'm going to round up, and your answer would be 14.05. So when adding or subtracting, round to the least number of decimal places. Look at all the decimal places for all of your numbers and round to the least number of decimal places. Lastly, a different rule when multiplying or dividing. When multiplying or dividing, we are going to round the answer to the least number of significant figures. So let's say I had 0.51 times 53.2, and when we put that in our calculator, we get 27.132. Remember, leading zeros are not significant, so that 0 is not significant. 0.51 only has 2 sig figs. 53.2 has 1, 2, 3 sig figs. We're going to round it to the least number of significant figures, which is 2. So I'm just going to keep 2 digits. The next number is less than 5, so I'm not going to round. My answer would be 27.